Hello, this is Luke. This is the next video in the series on building a sound detector. We've moved on from preparing our data, our training data, and now we're going to look at training the machine learning model. I'm not going to actually dive very deep into this, and my thinking is that there's so many tutorials on YouTube already that help you build image classifiers, even binary image classifiers. It's kind of like an introduction to machine learning. I'm certainly not any kind of expert on machine learning. I basically just followed those tutorials and built a basic image classifier for this. So I don't think I'm particularly qualified to do things in like the best way or know that I'm doing things in the best way with this. So I'm just gonna overview the code. I'm gonna post it in the description. I'll link to the code that I used, and you can adapt it to your situation as you see fit. So I will just kind of briefly talk about it here, hopefully just in a couple minutes, just to kind of give you a couple signposts, I guess. I imported a couple libraries like OS and CV2. CV2 just for getting the images and reading them, and then OS is just for handling files. And so basically I went through my positive and negatives folder and used CV2 to read these in as grayscale images. And then what I did is instead of them being in their separate folders of positive and negative, you can see here I'm adding them to a Python list where the image array is paired with a 0 or a 1. Class num is just a 0 or a 1. And so the positives all get a 1 and the negatives all get a 0. So instead of having two different folders of images, you now have one Python array or list that has an image and a 0 or 1 with it at each step. And then you can divide those, you can shuffle them, make sure they're balanced, make sure it's the same amount. That's essentially all I'm doing with this code here, is just bringing those in, combining the lists, checking that the zeros and ones go with the negatives and the positives, then shuffling that up and saving it. Oh, the one thing is I do reshape it, and that's just for the code that's where the destination that it's getting to is it needs to be reshaped in this way. So this is kind of an important little obscure piece of code here, is this reshaping the array or image file so that it feeds into the machine learning code appropriately. And then you just save it as pickle files. So pickle is just used for saving Python files. And so that's all that is there's this little page. It's a little bit verbose at times, but it's essentially just taking those folders of images and now turning them into pickle files that are like lists of all our input data, all the X's and all the Y's. And then what I did is I went over to Google Colabs, which is a place where you can do machine learning. It allows you to use their, use their RAM, because some of this stuff's pretty intensive in terms of processing. And so depending on what you pay for, whether you use the free version, you get things can run quicker because you're using their computers rather than just yours. So I bring in everything over here, and the one thing is I do normalize it so that it's all from 0 to 1 rather than from 0 to 255. You might remember from a couple videos ago that all the images were in RGB or RBG form, and from 0 to 255 each pixel, and now these images are going to be from 0 to 1. And basically that's it. It's just everything's coming in the X array and the Y array. Here I'm just checking that it's normalized, or like making sure it's normalized, I guess. This is just a simple equation for normalizing any data, really. Subtract the min and then divide it by the max minus the min, and you get, it ends up being between 0 and 1. And then it just moves into this is the machine learning section. And maybe the only interesting thing to say, like, it's going to add different layers, and if you go to a tutorial, you're going to basically get some sort of function like this, where you're adding different layers into the machine learning model. And one kind of cool thing about this is that it tries different amounts of layers programmatically. So these for loops changes the layer sizes, the amount of layers, and the dense layers and convolution layers. So it tries it again and again and again with different parameters, depending on how you set these up. So that's kind of, it's a good, like, with machine learning, you're kind of trying different parameters and hoping to find one that works well. And so it's kind of nice to do that programmatically, to maybe find that sweet spot of, like, oh, if I use 3 dense layers, it seems to work better. There's a bit of guessing and checking, I guess, and so it's good to programmatically do that. And then, yeah, you run it, and it's going to run through and hopefully get better and better accuracy. And at the end, you've got a model that you can save with model.save. And then you've got your model. So in this case, I put the date on it, and I've got a model that predicts an image, whether it's a hermit thrush song image or not. And in the next video, I'll show kind of what we can do with that model. So, I know this wasn't very, like, I just wanted to kind of address this fact that there's this kind of gap in the tutorial, but I guess it's like, I don't see that it makes sense to reiterate what people have already done probably better than I can do all over the internet with these kind of image classifiers. So if you need to, I would say go find one of those, figure out how to set up this in a reasonable way, and then kind of you can continue with the tutorial. And I'm kind of focusing on the lead up to this and getting the data, and then afterwards, what do we do with that model in terms of getting it back to our spectrogram and labeling it appropriately and using that information. So yeah, hopefully this is helpful. Like I said, the code is in the description, so feel free to check that out, and then check out the next video.